Hi, welcome to Practical Revit for Structural Engineer. I am professional structural engineer but not professional YouTuber. Sorry in advance for the quality of the video. The content will be in the form of a series of videos that will cover most often used in structural engineering, such as finite element modeling, rebars detailing, and quantities measurement. The video series will focus on the structural design of building with Revit. Finite element technology for 3D elements such as brick elements, enables the structural engineer to analyze and design a small part of a structure, such as structural steel connection. However, such 3D elements are not suitable for the structural design of buildings. Modeling all structural components in a building using 3D elements, such as brick elements, will cause a huge amount of degree of freedom, which will also demand huge computing power, then leads to inefficient loss of cost and time. For the structural design of a building, it is practical to estimate the structural behavior of beam and column using line element, which reduces a large amount of degree of freedom required in comparison with the brick element. And structural behavior of floor, or wall, could be estimated using area objects such as shell element, which reduces a significant amount of degree of freedom required in comparison with the brick element. The advantage of using line or shell elements for the estimation of building structural behavior, is not only to minimize the total number of degree of freedom, but also the interpretation of the structural analysis results from line or shell elements, are much easier than that of brick element. The structural analysis results from line or shell elements, are so-called member forces, which most of the time, are easier for concrete, or structural steel design, than the stresses, obtained from brick elements. For a pre-stressed concrete structure, or structural steel, that required stress under the serviceability limit state, or ultimate limit state, the stresses could also be obtained from line or shell element using the so-called plane strain remain plane assumption. As explained earlier, line and shell elements are the practical finite element model for the structural design of a building. And Revit is a great tool for structural engineers to prepare not only the design intent but also a finite element model, at the same time. So from now on, when I refer to a finite element model, it will refer to the model composed of line, or shell elements. Although Revit is a great tool for making a building model, however, it does not mean that, randomly making Revit model, which visually looks like a building, will automatically translate to the usable finite element model. Remember that Revit model composes of the geometry of volume-like, which is considered as 3D elements, while the finite element we need, is 1D or 2D elements, which are line and shell elements. Because of the dimensional difference between those two, therefore, the Revit model could not be accurately translated into a usable finite element without proper understanding and preparation. The direct converting Revit model into a finite element, without proper preparation, will often lead to a mistake in the finite element, such as unconnected nodes, or unintended structural behavior. And to fix such problem manually, later on, is difficult, and expensive. The next video will explain the technique, and good practice of how to model in Revit, in such a way that, it could be used, not only for 3D visualization, and documentation, but also, for structural engineering purposes, such as the finite element model, which include, modeling of structural column, structural wall, structural floor, pile cap, and, how to obtain pile coordinate for further used for foundation design.